Welcome to section 15 of KMF 170 puzzle. Here is a histogram. The dataset D consists of 35 values, all of which are integers. The frequency distribution of the values in D is shown in the histogram. Here, each interval shown contains values that are greater than or equal to the left-hand point but less than the right-hand point. So we need to find out the average arithmetic mean of the values in D and median of the values in D. So there are total 35 values and the median would be of possibly 18th values. So you can you can rearrange the number. For example, 26 is here for 3 times, 31 is here for 8 times, 36 is here for 6 times, and 41 is till 16 times. So 3 plus 8 plus 6 plus 16. You will get the 18th number in the interval between 41 to 45. So median will be, say, 41, as we can't consider the right values of the histogram. So how to find out the arithmetic mean? As the formula, take the left values and multiply with 3. Similarly, take the summation of all the multiplication and divide it by 35, as the total value is 35. So we get the average, that is 36.85. In this case, quantity B is greater. In the second question, there are two sets, set S and set T. The question is, how many different sets M other than S and T can be formed such that S is a subset of M and M is a subset of T? Symbolically, you can see it like that. So M cannot be as exactly as S and T. So we need to form set M from set T. We can form it in 3, 4, 5, 6 ways. What are those? 2, 4, 6, 8. So in this case, S is in M. S is 2, 4, 6, and M has one element more. And M is a subset of T. So T has 6 elements and M has 4 elements in this case. Similarly, we can go up to M that has 5 elements, but not exactly as T. So the answer will be 6. There is an alternative method. As the set T has 3 more elements, so 2 to the power n, that is 2 cube equal to 8. So null set and full set will have common in both sets. So you can take the difference of 8 and 2 and the elements will be 6. We are in the third question. The candies in a candy shop can be divided into unscented and scented, and they can also be divided into blue and green. There are 1000 unscented candies and 1000 blue candies. 25% blue candies and 50% of green candies are scented. When the candies which are neither scented blue nor scented green are sold out, how many candies are there still in the shop? So the question basically asks, how many candies are left out after selling out unscented blue and unscented green? So as there are 1000 unscented candies and 1000 blue candies and there are 2% is given, we can use the matrix. So how many scented candies are there? 25% of blue candies are scented. Okay, so there are 1000 blue candies and 25% of those are 250. So the unscented blue candies will be 750. That can be found taking difference between 1000 and 250. So now that 50% of green candies are scented. We don't know how many green candies are there, but we know that unscented candies are 1000, and we have found that blue unscented candies are 750. So take the difference between 1000 and 750, we get 250. So 250 is unscented green candies. This is the 50%. So other 50% will be obviously 250. So the total green candies is 500. So you get green candies are 500 and scented candies are 500. The question is neither scented blue nor scented green are sold out. So the unscented blue and unscented green are sold out. So among the total candies that are 1500, we have sold out 1000 candies that are unscented. So the remaining candies are scented. So 1500 minus 1000 equal to 500. Here's the fifth question. Of the people in a debating club, 24% are more than 55 years old and 68% are married. The question is the percent of the people in the club who are both more than 55 years old and married. We can use the Venn diagram in this case. Let us take two extremes. So as the 42% are the lower number, those can also be married. So the highest number will be 42% and the lowest number can be found summing up 42% and 68%, as those are greater than 100%. So 10% is more here. So the lower limit is 10% and the upper limit could be 42%. And the quantity B is given here as 26%. So the answer will be D. The relationship cannot be found from the given information. In a pool of 200 people who answered either yes or no to each of two questions, 170 people answered yes to the first question and 10 people answered yes to the second question. Which of the following could be the number of people polled who answered no to both questions? So you need to find out the number of people who answered no to the first question and no to the second question. Well, those who are acquainted with the game theory will find this method easy to deal with to find out the answer of this question. So total people is 200 and 170 people answered yes to the first question. So there are 30 people left who answered no to the first question. So get out the two groups, one of 170 and another of 230. In the second layer, those who answered yes to the first question has answered yes to the second question, and those people are 10 that is given in the question. So if we just take difference of 170 and 10, 160 people left out who answered no to the second question but yes to the first question. Similarly, those who answered no to the first question, those group are comprised of 30 people, and they answered yes to the second question. There are 10 people as given in the question, and 20 people left, those answered no to the second question. So people who answered yes to the first question and people who answered no to the second question are within the limit of 20 to 30. So the answer will be 20, 26. So what is asked in the seventh question? A college professor took attendance for the first 10 days of a class last semester. The professor noticed that Sarah attended class on 8 of those days, Andrew attended class on 7 of those days, Jeff attended class on 6 of those days, and on only one of those days did all 3 students attend class. On how many of the 10 days did at least 2 of the 3 students attend class? So take a sample strategy. So total days are 10 and Sarah attended 8 of those and you attended 7 and Jeff attended 6 and 3 of those attended 1 class, so mark it by. Okay, so 3 of those attended this day. It is possible that Andrew attended uh, a day that is not attended by Sarah. So in this case, we'll get the 6 days that is attended by Andrew and Sarah. And it is possible for Jeff not to attend 2 days that was attended by either Sarah or Andrew. So here we got 3 days out of 6 days for Jeff. So 6 plus 3 equal to 9 and 1 is common for all 3 students. So 9 plus 1 equal to 10. We can use an alternative system, for example, a plus b plus 1 as 1 is common for all equal to 8, that is for Sarah, and a plus c plus 1 equal to 7, that is for Andrew, and b plus c plus 1 equal to 6. Okay, now just sum of these equations. We'll get a plus b plus c equal to 9 and 1 in common, that is 9 plus 1 equal to 10. So the answer will be 10 days. In the 8th question, we can use a Venn diagram, I think. All of the 80 science students at a certain school are enrolled in at least one of the 3 science courses: biology, chemistry, and physics. There are 60 students enrolled in biology, 50 students enrolled in chemistry, and 35 students enrolled in physics. None of the students are enrolled in all 3 courses. Which of the following could be the number of students enrolled in both chemistry and physics? So students who are enrolled in biology may not be enrolled in chemistry and physics. So we can find out the number. 80 minus 60 equal to 20. And we can take another way, that is 50 plus 35 that are attended by chemistry and physics. And as the total number of students are 80, so we take the difference of 50 plus 30 minus 80 and we get 5. So number of students enrolled in both chemistry and physics could be between 5 to 20. So it will be 5, 10, 15 and 20. In this case, we have found out the 2 extreme values and then use that as a range. In the 9th question, they provided a sequence. In the sequence says, a1 is an integer and at equal to 2, a(n minus 1) for all integers n greater than 1. If no term of sequences is a multiple of 100, which of the following could be the value of a1? So the condition is no term of sequences is a multiple of 100. Okay, so a1 equal to a1 and a2 equal to 2a1 as given by the equation, and a3 will be 2a2 and a2 equal to 2a1, so a3 equal to 4a1. Similarly, a4 will be a21. So take each values and test the options. So if a1 equal to 5, a2 equal to 5 into 2 equal to 10, and a3 will be 10 into 4 equal to 40, which is not a multiple of 10. In this way, we'll test the other options and we'll get that only 50 is the multiple of 100, that is 50 into 2 equal to 100. So all other options met the condition and that will be the answers. In the last question, the term C1 of a certain sequence defined by a n equal to 3 by n into n plus 1 for all integers n greater than equal to 1. Quantity A asks for the sum of the first 100,000 terms of the sequence, and the quantity B is 3. So in this question, we can use split and cancellation method. Let's try it. So 1 by n minus 1 by n plus 1. And we get, after the calculation, 1 by n into n plus 1. So as quantity B gives us a number that is 3, we can put it in our rule or formula or equation, whatever it is. So 1 by n equal to 3, that will be 3 into 3 plus 1 equal to, we get 1 by 12. So 1 by 12 is less than 3. So in this case, quantity B will be greater than quantity A. That's all. Thank you.